All right, kiddos. So we're going to talk about static electricity today. And hopefully I don't get too cold out here. It's a beautiful day, but it's windy, and you know me, I get cold really easy. So we're going to talk about static electricity. So like static electricity are those moments where like, okay, you're taking off a hat and your hair stands like straight up on end, or you're doing something and then you reach for something that's maybe metal and you get shocked, right? Like the door handle, or sometimes you just touch your friend and you get shocked and you're like, what is happening? So that's static electricity. So for us to really understand static electricity, there's a couple of things that we need to kind of review first. And one of those is just like what an atom is. Okay, so an atom is made up of a neutron, which is in the nucleus, right? And it has no charge. It just is in the center of the atom. Then it has protons that have a positive charge and are also located in the nucleus. So we've got protons and neutrons. Neutrons got nothing going on. Protons are positive, and they're chilling in the center of our atom. And then electrons have negative charges, and they're outside of the nucleus, so they are kind of all around this center of our atom. Everything is made of atoms. So we've got protons, neutrons, and electrons everywhere. A static charge happens because electrons will move from an object to another object, and it also builds up when objects and materials are like touching. So sorry, this is taking forever to load. My internet is super slow today, per usual. Okay. So static electricity is kind of unique. It's not the same as the electricity that we talk about when we talk about like going through electrical lines or the lights in our houses, or even our cell phones. Though that's not the same type of electrical energy. So like that kind of energy is produced because we can control how the electrons flow like along these wires, but something that's static isn't moving, it's just staying still. So how does electricity stay still? That's what we're going to find out. So like we said before, all objects have electrons because all objects are made of atoms, right? So the electrons can be set in motion just by contact with another object, or by the objects moving against each other, so like rubbing up against each other. So what happens is that these electrons kind of jump back and forth from object to object. So as things bump each other or touch each other or up against each other, one object may gain electrons while the other object is going to lose electrons. And so, remembering that electrons have a negative charge, the object that ends up with the most electrons is negatively charged, while the object that ends up with less electrons has a positive charge. So when this is unbalanced, the charge is called a static electricity. So this unbalanced amount of electrons is what gives us static electricity. And it's not moving, it's stored energy. So it's like just chilling inside whatever it is, whatever it's on. And that energy is stored until it's released. And so different objects store static electricity differently, because there are some objects that really easily give up electrons and some objects that don't give up electrons very easily at all. So for example, like skin and human hair, those tend to give up electrons pretty easily. Hard rubbers, like you might find in a comb or a brush, those tend to take electrons really easily. Same with like things that insulate, so like wool or fur, or like the material of your clothing, those tend to not very easily conduct electricity, whereas like materials like metal, like the metal tray that our markers sit on at the whiteboard, that has electricity very, very easily. So that's why like when you touch a metal door handle or things like that, you can feel that static electric shock. So another thing that can cause some changes is friction. So friction happens when like one object is rubbing up against another object. So like if you're wearing socks and you scoot across carpet, that's going to create friction. And friction is another way that causes electrons to move between objects. So that's just another thing that can sometimes cause those changes in that static electricity buildup. So objects that have a static charge have it's like a unique property, and that property is that any object can have a property or a positive or negative charge, but since electrons are negative, the more electrons that the object has, the more negatively charged it becomes. An object that has more protons versus electrons is going to become positively charged. If there's one that has the exact same amount of electrons and protons, then it's just neutral. So it has no positive or negative charge, it's just chilling. But objects with different charges, they interact differently. So objects with the exact same charge, they're going to repel each other. So like two negative magnets, you're not going to be able to put them together. They're going to push away from each other. But objects that have the opposite charge will attract, and so those things will come closer together. And we see these things happening pretty regularly in our days. They show a video in here that gives you a lot of examples of just daily times that we see these positive and negative interactions. So static electricity doesn't move, but each charge can move just once. So that static charge is the imbalance of electrons, but they want to be balanced. And so that's why when you end up touching things or something like that, you get that static discharge, that shock, and that's that one time that it moves and then it becomes neutral. So those charges are gone and both objects become into a neutral state. We already talked about that. So you're going to notice static electricity a lot more on dry days and in dry weather. The reason for that is because water is actually a conductor, and so in wetter weather, rain, humidity, electrons can move really easily, so you don't have that buildup and you don't have that same amount of stored energy, and so you don't have that one-time big release to get back to balance. But on a really dry day, you're gonna see more often impacts with static electricity. Same with like your hair. Your hair is gonna have that, if you rub a balloon on top of it and it sticks straight up, that's gonna happen more often if you have your hair dry. If your hair is really wet, like you just got out of the shower, you're really not gonna see that. We do find static electricity in nature, and that's lightning. Lightning is a discharge of a huge static charge. So the wind moves the warm air, cold air, water, all the other particles inside the clouds, and it causes a lot of positive and negative charges. So the negative charges collect at the bottom of the cloud. And because opposite charges attract, positive charges are collected on the ground under the cloud. And so when the difference in the charges becomes big enough, we see that big lightning flash. All right, guys, I think we're on to just reviewing our key concept here. So, key things to remember, if it will load. There we go. So static electricity is a buildup of electrical charge in an object. So that's just the definition. When does static charge build up on an object? It can happen when you're rubbing two objects together. It happens more easily in dry weather. And then what happens when a static charge builds up on an object? So static charges can cause objects to have positive and negative charges, and so they can repel or attract each other. And those static charges can be released as like a spark of electrical energy. And when it happens, we feel this shock. And then what's an example of static electricity in nature? Lightning. And I think that's about all we've got, so I hope that helps.